boys and girls of St. Lucie Public Schools. I am Miss Owens, the math coach at Longwood Elementary, and thank you guys for tuning in with me. In today's lesson, we will continue to work with cookie problems or fraction circles, but instead of trying to figure out the best way to share them among groups of people, we will work with how to determine who has more and who has less, also known as comparing fraction circles. So, before we begin, I want you guys to know that when you are trying to figure out who has more or who has less, when you're dealing with fraction circles, both of the wholes must be the same size. You cannot compare fractions using fraction circles if you're using a teeny tiny circle and a really large circle, or a medium circle and a small circle. Both circles must be the same size. So, let's get into the lesson. Two students are going to get a piece of a circle. One of them will get half of the circle, and the other will get 3/4 of a circle. So how do you determine which of the students is getting more? Will it be the student that will get half of the circle, or will it be the student getting 3/4 of the circle? So at this point, we are trying to determine which will be more, half or 3/4. Do you remember how to write those fractions? I bet you do. I'm going to write them down on the board.
Nice and large enough so that you guys can see it.
I'm going to put a space in between the two fractions because I want to put the comparison symbol there. Remember, when we are comparing numbers and fractions, we use symbols like the greater than symbol, less than symbol, or equal to. Now, how can we determine which is a larger fraction? Well, lots of times people take a look at fractions and they look at the numbers, and they usually, when they really don't understand that fractions are about size, they'll pick the fraction that has the larger numbers. But we're not going to do that because we have been working really hard at understanding fractions. So how can I take one of these circles and fold or cut it to represent half of the whole? Maybe so. So I'm going to go ahead and take this circle and I'm going to fold it in half. I'm going to line up my ends so that they are overlapped, that they overlap evenly. And then I'm going to press out my fold. And here I have folded the circle in half. Now I am going to cut the circle and label the two parts, but I just want to take this opportunity to review what we know about half. When you cut, partition, or fold something in half, you fold it into two parts. So I still have one whole circle, but when I cut it, it will be broken into two equal sized parts. And I'm just cutting on the fold. And I will label this part as 1/2. Now let's talk about the fraction 1/2. Before I cut and folded this whole fraction circle, it was just one whole piece. But when I cut it in half, I ended up with two equal sized parts. Let's talk about the actual fraction. The number at the bottom, also called the denominator, refers to how many parts the whole was cut into. So let's review. How many parts was the whole cut into? 2 equal-sized parts.
Good job.
The number at the top of the fraction, also called the numerator, refers to the amount of the whole that is being described. I know that I have 2 parts, but when I look at this piece right here, how many of those 2 parts am I referring to? Just 1. That's why the numerator has a 1, because this half of a circle represents 1 of 2 parts. And the line in the middle is the fraction bar. This is 1/2. So we're going to take the other 1/2. I'm going to label it. And I will put it aside for now. So, how do we take the other fraction circle and use it to represent 3/4? Let's examine the fraction. Well, Miss Owens, if the denominator or the bottom part of the fraction tells me how many equal-sized parts I need to fold or cut the half into, then I am predicting that you are going to fold or cut this circle into 4 equal-sized parts, also known as fourths. You would be absolutely correct. So what would be the best way to fold this circle to get 4 equal-sized parts? Very good response. I'll try that. So I'm going to fold it in half, just as I have done the first circle. I'm going to fold it in half. If I fold a whole in half, how many equal-sized parts do I get? 2. Half is 2 equal-sized parts. Then I'm going to take this and I'm going to fold it in half again. And this is how you get your 4 equal-sized parts. So now I have fourths. Each of these parts is one of the 4 parts. It's 1/4. So I'm going to go ahead and label the parts. This part is 1/4, and this part is 1/4, another 1/4, and another 1/4. And I'm going to go ahead and cut these out. And you're just going to cut on the folds. Now, as I am cutting out the 1/4 size parts, I'm thinking about just the size of one of these pieces compared to the size of the half. And I'm noticing that just one of these 4th size pieces is smaller than a half. This is 1/4 size piece. So I'm noticing that 1/4 is smaller than in size than a half. Here is the half and here is the 4th. So just one of them is smaller than one of the half sizes. Okay, let's go back to the original problem. How many 4th size pieces do I need? Do I need just 1/4 or do I need more than 1/4? I need 3 4th size pieces. So there's 1/4. 2/4. Wait a minute. Do you see what I see? Do you see a pattern between 2/4 compared to just half? One half and 2/4 are the same size. Do you remember that word when two fractions are the same size? They take up the same amount of space, and they are, when we're doing rectangles or fraction strips, they are the same length. Equivalent. Awesome. So 2/4 is equivalent to the size of just 1/2. But I don't need 2/4. I need how many fourth size pieces? I need 3. So I'm guessing that 3/4, it's probably going to be more. It's probably going to be bigger than a half. But let's finish and let's find out for ourselves. So that's what 3/4 look like. Part of it looks like half, but then you have half and you have more. Don't pay attention to the old eighth. Let me get that out of the way so it doesn't confuse you. When you look at 1/2 and you look at 3/4, which is greater? The 3/4 are greater. Do you remember the greater than symbol? The gator looks like he wants to eat the 3/4, and his back is turned to the half because he realizes it's not as much. So read this with me. I'll read it once and then I'll read it again and you can join in on the second half. 3/4 is greater than 1/2. Now let's read it together. 3/4 is greater than 1/2. You guys are amazing. I hope by now you have taken the time out to make your own fraction circles. If not, make sure you have something to write with and something to write on, as well as your workspace journal. And we're going to draw out the circles. Remember, when you are using fraction circles to compare fractions to see which is greater or which is less, the circles must be the same size. Remember when I initially started out with my circles, they were the same size. You can't have big circles and small circles. So, a follow-up for this lesson is on page 34 in your workspace, and it reads, who has more? So let's take a look at the problem on page 34 in your workspace journal. Now at this point, we're just going to draw them out. So we won't be cutting any more circles. We'll just be drawing those circles out, and we will shade the portion that we are trying to take a look at. So let's go ahead and get into the workspace lesson. And it reads in the directions, Bill has 1/4 of a circle. Rika has 3/8 of a cookie. It says, cut cookies as needed, paste and label the cookies. We're not doing that. We're going to draw them in shade. And it says, who has more? How do you know? Okay, so let's write the two fractions that we are comparing. We are comparing 1/4 to 3/8. So I'm going to come underneath and draw a circle. And I'm going to try to draw a circle that is the exact same size as this first circle. I think that's pretty close. All right, so let's take a look at the denominator. We're going to deal with one fraction at a time. We're going to examine the fraction and draw the matching model, and we're going to check our work. So this is 1/4. Remember, the denominator tells me how many equal-sized parts the whole has been cut into. That's going to bother me. I need to adjust this just a little bit. Okay, here we go. So since the denominator is a 4 here, I have to take this whole circle and I need to part it into 4 equal-sized parts. Do you remember how we part circles into 4 equal-sized parts? Absolutely. We're going to pretend that that's a fold. We can draw a line sectioning the circle in half. And then we take each half and we part that half in half. Okay? And we're going to go ahead and label the parts of each section of the circle. Awesome. Now, we're not going to shade anything, but we just want to verify that we have taken one whole circle and we looked at the denominator and we realized that, hey, this fraction represents a whole that has been cut into 4 equal-sized parts because that's what the denominator tells us. So now we're going to take a look at this fraction. Well, when I look at the denominator in that fraction, there's no 4 there. In fact, there's an 8 here. So how many equal-sized parts do I need to cut this whole circle into? 8 equal-sized parts. How do I take a whole circle and partition or part it into 8 equal-sized parts? Let's try half, because it's easy to cut something in half. So if I draw a line down the middle, and I part the whole into halves, then I know that I can take the halves and part those in half by drawing a line across the center. Do I have 8 equal-sized parts yet? Not yet. I can take each one of these 4 parts and part those in half by drawing a nice even line from the center to the outer circle. And that, my friends, is how you get 8 equal-sized parts. Now I need to label each of these 8 parts. Do you know what I should write as a fraction in each part? Well, I know that when I was looking at the fourths, each one of those parts is one of the 4 parts. These parts don't represent one of 4 parts. They are one of 8 parts. How do I write that as a fraction? 1/8. Good job. You know how many times I'm going to have to write 1/8? 8 times, because there are 8 parts here. So go ahead and label your fraction, your circle, your fraction circle. And at this part, I do want to just make sure that I count my circles, my parts to make sure that there's 8. So I'm going to just put a dot here so that I know that this is my starting one. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. Yep, I have 8/8. Okie dokie. Now, remember we're trying to figure out which is more. 1/8, 1/4, or 3/8. So if I was going to shade 1/4, I would only shade one of the 4 parts. Okay. Now, before I move over here and I start shading to show 3/8, I just want to point out that this section of 1/4 is about this section here. How many eighths cover this section? The section of a 1/4 part. 2/8. This fraction represents 3/8. So I'm going to need to shade more of this circle than just this part. Let's go ahead and shade 3/8. 1/8. 2/8. Hey, 2/8 looks like 1/4. And 3/8. So which is more? 1/4 or 3/8? Remember, when you are comparing fractions, you need to use those symbols: greater than, less than, or equal to. Which is more? Which has more of the whole shaded? The 1/4 or the 3/8? the 3/8. So the gator's mouth is open to the 3/8. Good job. He wants to eat it. And his back is turned to 1/4 because he knows that it is less. It's less than the 3/8. So let's read this comparison statement. I will read it first and then I'll read it again and you can help me. 1/4 is less than 3/8. Now let's read it together. 1/4 is less than 3/8. Miss Owens, those symbols look the same. I know the equal sign when I see it because it's two lines, but sometimes I do not know how to read those greater than or less than symbols. How do you know which is which? Well, thank you for asking. I will explain. The back part of the gator, of the greater than sign, points away from the smaller number. The mouth is always open to the larger number. And because when we read, even if you're just reading your favorite book from the library, you always start on the left side. And when you write your name, you start writing your first letter on the left side. So because we read and write from left to right, that's how we read the symbols. If the mouth is open first, then it's greater than. If the back is turned away, then it is less than. 1/4, the back is there, is less than 3/8. Got it? Good. Let's do one more practice here. The next practice will come from, let's take a look in your workspace, page 39. Now this one is a little bit more challenging because we're working with fractions that are greater than 1, improper fractions, and mixed numbers. So it reads on page 39, Kiko has 1.5 cookies. Let's write that down. 1.5 cookies. Jason has 5/4 cookies. 5/4 cookies. It says, who has more? And how do you know? Whoa! 1.5 cookies. What does it look like to have 1.5 cookies? Well, remember when you're looking at mixed numbers are made up of whole numbers and fractions. So he has a whole cookie and a half a cookie. And then when you're looking at improper fractions, the numerator is larger than the denominator. I like to think of improper fractions as two cousins giving each other a piggyback ride. And the big cousin is on the little cousin's back. And the little cousin is saying, get off of me, you're too heavy. And you're like, that's not right. The little kid gets on the back, the big kid carries them. So when you see fractions that have larger numbers on top, smaller numbers on the bottom, they're not proper. They're improper. And they have a value that's greater than 1 whole. All right, let's draw our pictures to represent these fractions. 1.5. 1 whole and a half. So we're going to go ahead and draw the whole and the half. That's what 1.5 looks like. Is there another way to represent 1.5? Well, let's take a look. If I look at the whole and I look at the half, can't I also partition that whole in half? And now I'm looking at how many half-sized pieces. 1 half, 2 half, 3 halves. So 1.5 is also the same thing as 3 halves. Right? That's the improper version of that mixed number. 1.5 is equivalent to 3 halves. Now let's take a look at 5/4. Again, in looking at the denominator, I know that the size of these fractional parts are fourths. And as I cut out This is the size of 1/4. And looking at my numerator, I don't just have one of these. I have 5. I have 5 of these pieces. So let's take a look at what 5/4 looks like. Do you remember how many fourths comes in one circle? I folded it. I cut them out. How many parts did I get when I parted the circle into fourths? 4 parts. So, if I was to take a circle, let me just try my best to do that one again. Take a circle and part it into fourths. I'm going to cut it in half, and then I'm going to cut each half in half. I'm only going to get 4 1/4 parts, or 4 fourths. This fraction doesn't say 4 fourths. 4 fourths looks like this. This fraction says 5 fourths. So I'm going to need an extra fourth size piece. 5 fourth size pieces, that's actually 1 whole and 1/4 size piece. So the mixed number version of 5 fourths is 1 whole circle and 1/4 size part. So we found a way to look at how these fractions can be written 2 ways. I can represent 1/2 as 3 halves, because if you start parting that whole, you're going to get 2 halves out of it. I can look at 5/4 size pieces as 1 whole and 1/4, because you can take 4 of these fourths and put them back together like a puzzle and you'll get 1 whole. Now back to the question. Which is more? A whole pizza and a half a pizza? Or a whole pizza and a fourth of a slice of pizza? Or a whole cookie and a half a cookie? Or a whole cookie and a fourth of a cookie? Or is 3 halves more than 5/4 size pieces? At this point, you should really start to see fractions are about size. It's about the size of a whole. And the numerator, the top part, tells you how many of those sizes you have, how many of those pieces you have. So let me ask you something. Your favorite cookie in the whole wide world, the one that you love to eat, maybe drink with milk or whatever your favorite drink is, would you rather have 3 halves of that cookie, or would you rather have 5/4 of that cookie? Because you want more, right? Would you rather have 1 whole of that cookie and a half size piece, or would you rather have 1 whole and a fourth size piece? So let's bring it on home. We know that the whole will be the same size either way. What will make the difference is that little extra piece that you get. Because at this point, they are equivalent. But when you take a look at that extra piece, would you rather have your extra piece this size or your extra piece this size? I'm going with the half too. So that helps me to understand that 1.5 is actually greater than 5/4. Because 5/4 is equivalent to 1 whole and 1/4. Chomp, chomp. All right, let's read this. I'll go first. 1.5 is greater than 5/4. Now let's read it together. 1.5 is greater than 5/4. You guys are super duper amazing. Give yourselves a pat on the back. Boom, boom, boom. Thank you guys for tuning in with me. It has been my pleasure. I want you guys to keep working on those problems. You're going to continue to work on the problems on page 39, and I will see you next time.
Thank you.